negative exponents, which you know, is actually is pretty difficult at first, I guess, or maybe just pretty difficult altogether. Then it kind of brings in some scientific notation, which you may have had. I think it's in Math 20 or something they talk about it. I can't remember. I know it's in one of the courses, but I probably picked it up somewhere. I guess that a couple of people have told me that they've used it in some of their science classes. You know, if you're like taking nursing or something like that, I guess. It's there. So we'll do that. But it's not anything that's really difficult. But the negative exponents kind of is. The supplement that I pushed back till tonight because we were only covering one section is really short. So that's not going to take us too long to do either. So yeah, that's pretty much what our plan is. So again, we won't be here for too long. And then if you have anything you want to talk about before your test Wednesday. So again, I think Wednesday, right? We're just going to come in and you can ask me any questions you want on your assignment or any questions that you want. Then I'll give you the test, and then when you're done with it, you know, you can go. So I've just never been a big believer in giving a test and then doing more stuff. I don't know why people really do that. So I don't do it, but anyway, that's going to be our schedule then. So we'll go ahead and get started here then. So we've been building on these properties of exponents. I think that's what I was calling them. Properties or the laws of exponents. We've been building on those. All right, so I'm just going to repeat them, but you sure don't have to write them down again because you've already got them. Okay, so then I think there was 5 of them that we had. Anytime you multiply, you're going to add the exponents. When you divide, you subtract the exponents. When you're raising to a power, you multiply the exponents. You know, a fraction to an exponent, you just kind of bring it inside, multiply to what's there. And then anything to the 0 power is 1. Okay, so those are the properties or the laws of exponents. The 6th one says a to the negative n is equal to 1 over a to the n. All right, so if we take a number to a negative power, then it just flips. So for example, pull up my little calculator here. If I go to, let's see if I can get this to work, 2 to the 3 negative, it's 0.125, which happens to be 1/8. All right, so if I go 2 to the 2 negative, then it's 1 over 2 to the 2nd, or 1/4, which is 0.25. So that's what a negative exponent does, is it just takes and brings down this, okay, so whatever power this is. Notice that the negative goes away, all right, so you don't have it there. So once you move it down to the bottom, the negative goes away, okay. you're taking care of the negative by moving it to the bottom. All right? So what kind of things can we, so now that we know what the property or the law is, let's see what kind of things we can run into. Well, we're going to simplify because that's what we do in Math 65. So let's go ahead and do some simplifying here. So first of all, let's start off with some numbers. So let's go with 4 to the negative third. All right. So that's just going to be, move that down there, equals 1 over 4 to the third, okay, which is 1 over 4 to the third. See, 4 times 4 is 16 times 4 is 64. All right, so we take the negative exponent, because it's negative, it's going to pop down to the bottom, and then we just figure it out from there. 4 to the third, use your calculator, and you can get it. All right.
Do we have to put that into a decimal then?
No, you probably just want to leave it like that. Okay. Negative 3 to the negative fourth. Okay, so here the negative is not in the parentheses with the 3. So then I'm just going to go 1 over 3. I'm going to stick a negative out in front to the fourth. And then 3 to the fourth, 3 times 3 is 9, times 3 is 27, times 3 is 81. So it's going to be a negative 81 over 81. Okay, so again, the negative exponent is going to move that down to the bottom. Okay, and then you work with it from there. All right, so you're thinking, oh, these negative exponents aren't really that bad. Well, what happens is that, of course, you know, in mathematics things get a little more complicated. Right, so if we have, let's just step it up just a little bit. So we have an x to the negative third here, and we'll go with 5x to the second here. Okay, then what happens is these are going to move down here to the bottom and join up with these ones. Okay, so they're going to move down to the bottom and join up. So this then would be 4. We can't do anything in the 4/5, that just stays. So these x's are going to come down here. Okay, so the 4 is all by itself. I get a 5 down at the bottom. Nothing happens with those. And I get x. And if I have 2 and then 3 come down, how many do you think that gives us? 5, yeah. Right, because we have 2 and then 3 come down there, and that gives us x to the 5th. All right, so it's just kind of like multiplying x to the second and x to the third, because you're bringing it down. All right. So let's go with 3x to the second, and then 4. So I'm just making these x to the negative fourth. All right. Now, in this case, the negative's on the bottom. So there really isn't any place for it to go because it's already on the bottom. So then it's going to move up to the top. Okay. So then it's going to come up here, join up with the x's squared that's up there. So that's going to be 3x. Those 4 come up, and how many x's are we going to have on the top now? 6, right, and that 4 stays there. See, with the x to the negative, it's going to pop it up to the top because there's no place for it to go on the bottom. There's no bottom, so it moves up to the top. So that negative exponent is sort of like a switch, I guess. So if it's on the bottom, it's going to go to the top, and if it's on the top, it's going to go to the bottom. So it's kind of like a light switch, right? Okay, something like that. You can think of it. Any questions on what we're doing there with those?
So when it goes to the top, it changes, the negative goes away?
Yeah, whenever you move it from the bottom to the top, or from the top to the bottom, that negative goes away. Okay? Okay, so then what if we have one like this? Now we got negatives all over the place, right? I got a -5, okay, and I got a -2, and I got -5 here. So we got negatives all over the place. All right, so while we don't have to worry, these is just a regular, we can just go ahead and simplify that. All right, so we don't have to worry too much about that particular part. So that's just going to go to 1/2. I'm just going to put a 1 there for the heck of it. I know I don't need it. What's going to happen to that x to the -2? Where is it going to go?
Down.
It's going to go down, right? So how many x's are we going to have on the bottom? 5. Good job. And then what about that y to the -5th? Where is it going to go? It's going to go up to the top. And how many do we have? We have 9 up there. And then that's done. See? So again, what? Oh, yeah. I was looking like, what did I do wrong? There we go. And I don't really need a 1 there. I just put it there so that you can see that I reduced that fraction. Okay? But you don't really need it. So if it's on the bottom, it's going to go to the top if it's negative. And if it's on the top, it's going to go down to the bottom, and they're going to join up. Okay, so then let's just keep... All right, now we got one like this. Okay, so now I have more negatives. I don't have anything out front here. I have negatives here, and a negative here. Okay. So I'm just there's a couple ways to do this actually. All right, and this is one of those situations where you kind of got to do it the way you understand it. First of all, we'll just go ahead and take care of that 4/6. We don't want to mess with that. Okay, so here's one way. We could take the negative x to the -2nd. Where's it going to go? Where would x to the -2nd have to go? It's got to go to the bottom. Okay. Oops, except it's not negative anymore. And then where's that x to the -4 going to go? So it's going to go to the top. Okay, so then we could do that. All right. And then what about that y to the -1? Where's it going to go? So then we're going to have y to the 4th. Okay. Now I would just say, okay, I have no negative exponents. This is great. I can do this problem because I know how to reduce those. So how many x's are we going to have on the top? 2 on the top, y to the 4th on the top. The x squared here is gone, so now I have 3. All right? Okay, so you can do it that way. All right, and not trying to confuse you or anything, but you could do it a different way. All right, you could take these, here let's do this 2/3 first. All right, and if you apply that property of exponents, which says you're going to take this one and you're going to subtract. Okay, so you're going to subtract the properties of exponents. All right, and you can work it out that way. So if I took this -2nd and I subtracted a -4, notice that I get 2, so that would be x to the 2nd. All right, and then that negative was going to go up to the top. Okay, so you could do it that way. All right, depends on how you want to do it. You know, if you use your properties of exponents or laws, it says you're going to subtract these exponents, which we could. So -2 minus a -4 becomes a plus. Okay, so that's a -2 plus 4, which gives me 2. And that's how that works. So you can, again, it's kind of up to you the way you understand it. All right. So let's take a look at another one of those because that's like kind of a crazy one. So let's go with 4 x to the -5th, y to the -2nd over 6. I think I just did that one. Let's do a 12 x to the -2, y Okay, so if we did it, first of all, we need to reduce that 1 and 12 or 4 and 12 thing. Okay, so if we did it the first way I showed you, where's the x to the fifth, negative fifth, where's that going to go? Down, right? Okay, what about this x to the negative second? It's going to go up. And then y to the negative second is going to go down. So we're going to have how many y's on the bottom? 3, good, because you already got 1. All right, so you're going to have 3. Now we can simplify this. Okay, so how many x's are we going to have, and where will they be? 3 on the bottom, good. All right. So I think it's kind of depends on how you like to do these, you know, whether you want to use those properties or not. We talked about that once before. If you're a real property person, show me how to do it, and I'll follow the rules of math. Then you can do it this way. If not, then you might want to try just kind of breaking it down and using that negative exponent idea. Okay, here you'd have negative 5 minus negative 2, because that's where that negative 2 comes from, plus plus. See, we get x to the negative third. So we get 1 over x to the negative third over 3 y to the third, because it moves down. Then this negative would have to pop down there. So if you did it using the properties of exponents, then it would look something like that. Okay, you'd have this negative 5 minus a negative 2 plus plus, that gives us a negative 3. Can't have a negative exponent on the top. It comes down to the bottom like that. Okay. So again, it's kind of your way. You find your way that you want to do it. So we're still simplifying. Just when you thought it couldn't get a whole lot harder, they have something like this. Okay, so they give you something like that. All right, so they put stuff in parentheses, and then they put a negative outside of the parentheses. Okay, and again, there's 2 ways to do this problem. Okay, so you got to find your way that you like and then go with it. Okay, so one way, okay, would be to take this negative 2 and apply that exponent law, which says you're going to take that to each and every one of these. Each one. Okay, it looks kind of like a mess, but that's what you would do. So I would have 2. I guess I could probably reduce this. So I'd have 1 to the negative second, x to the negative 4, y to the negative 6, over 2, x to the negative second, y to the negative fourth. All right, so then you would take this negative 2, you're applying those laws, right? Reduce 2 times 2, 2 times 3, 1 times 2, 2 times 2, and then we get this mess. Okay, where you would go ahead and then say, all right, I know the 1 and the 2 are going to just stay there. They're just not going to happen to them. Okay. Actually, no, this should be negative 2 here. Yeah, and that should be negative 2 there. So they're going to flip. It's going to be like that. X to the negative 4, that's going to go to the bottom. X to the negative second, that's going to come to the top. Y negative 6 is going to go to the bottom. Y negative 4 is going to go to the top. Okay. It's a crazy problem. Then we would reduce this. Reduce this. And that's it. Yeah. Okay. But again, there's another way, right? So if he didn't understand that way, he's like, I have no idea what he's talking about. Okay, there's another way, all right, that, you know, I would probably do it this way. Okay, so let's start with the same problem. So here we go. 2, 4, x to the second, x to the fourth, y to the third over y to the second, to the negative 2. Okay. So here's what I would probably do it. Okay, I'm going to work inside the parentheses first because, you know, we've been taught that order of operations is you always do what's in the parentheses first. Okay, so let's do that. So let's do what's in the parentheses. So I'm going to go 1 over 2, reduce that. Okay, then we're going to reduce this right here. So I'm going to get x to the second on the bottom. Okay, then I'm going to reduce this one. So I'm going to get a y on the top. Okay. Oh, that's the negative 2. I think I must have messed this one up here. I don't know what I did wrong. Then I got a negative 2. Okay. So now I have a negative. So I know what a negative is going to do is it's just going to flip it. So then I'm going to go 1 and a 2. So the 2, 1, and they're going to flip. This y is going to go down, and this x to the second is going to stay. So all I did there was say, well, I got a negative exponent, and I know that when I have a negative exponent, everything flips. So this goes here, this goes here, this goes here, this goes here. And now I just square everything. So I'm going to get 4x to the fourth over y squared. Now I don't know what I did up here to mess this one up. Somehow I got it all messed up there. But this is right. So we'll try another one. Maybe I won't mess this one up. So there's just two ways, so basically. All right, you can pick your way. You can either do what's inside the parentheses first, get that down, simplify it, then bring in your negatives. Okay, so we'll do one like this time. See if I can not mess this up. Alright, so we got this. Okay, so this time I'm just going to use my properties of exponents first. Then I'll simplify it. But I can simplify this 3 over 9 because no matter what, I know what's going to happen there. So I'm going to get 1 to the third, or 1/3. Okay. Then let's see. So I'm going to go here. I'm going to put a negative 3 here. I'm going to put a negative 3 there. Negative 3 times x there is going to be x to the sixth. X to the negative third on the bottom. Y to the negative 12th up on the top. Y to the sixth on the bottom. And that's done. So I bring that negative 3 inside to each and every part. I reduce this down, that's how come I got 1/3, 6, negative 12, negative 3, and 6. So I have negative exponents, so anytime I have a negative exponent, things are going to go and flip. So the negative 1's got to go to the bottom. The 3 to the negative third is going to go to the top, become 3 to the third. This x to the 6 stays. But this x to the negative third is going to go to the top. This y to the negative 12 is going to go to the bottom, but the y to the 6 is going to stay. Three times 3 is 9, times 3 is 27. And that's what that looks like. Okay, so that would be doing it, all right, by taking and applying that negative 3 in there first. Okay. So if we did it the way I would have done it, okay, so I'm going to work inside first. All right, simplify everything that I got inside the parentheses, then I'll deal with the negatives. So I have 1/3. Come on. There we go. Okay, back in business here. So then now this x is going to go up to the top. The x to the 3rd there. This y to the 4th is going to come down here to the bottom. Okay, so all I did is simplifying that it's inside, right? Now I'll apply the negative. So I'm just going to flip them. 3 is going to come into the top. Y to 6 is going to come to the top. X to the 3rd is going to go to the bottom. I got a 1 down there, but really don't need it. The negative's now gone. So now I can just cube them up. And this time it does work out. Pretty sure that's what we got 4. Yep. How come I got them flipped? Gosh dang it.
-2 go on the bottom.
So -3, so that's going to go there, that's going to go up there. I got the powers right, but for some reason I'm not getting the things right here. So this x to the 6, so that goes there to the top.
The x -2 at the bottom, now wouldn't it go down?
The x, which one?
Down at the bottom where it's purple. The purple handwriting. The 3x -2, would that go on the bottom?
Oh yeah. What in the heck was I thinking? Thank you. I was flipping before I was wanting to do it. There we go. I knew I had the powers right. Thank you. So that's how that works. Okay. But you don't have a whole lot of those ones. Okay, they're pretty. Those are pretty tougher ones that I was giving you there. So, any questions on the negative exponents? On the scientific notation, So basically on the scientific notation, what the whole premise is to take a large number and write it smaller. Okay? That's the whole idea behind it. So here, what you want to do when you write something in scientific notation, you always want one number to the left of the decimal point. Okay? So we need to have 1.32. You just always want one number. These numbers to the right of it, you can have as many as you want, but this one here, we just want one there. So now we're just going to count 0. So the decimal point is here, so then I just need to count, well, how many moves will that take to get me to here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then that's 10 moves. So I'm going to go times 10 to the 10th. All right, so that's how that's written. A lot of your calculators will do scientific notation. It kind of depends on what you have. They might have, like your calculator screen will actually look like this, but the actual button is a EE key, okay? And that actually means times 10 to the 10th, okay? Or 10th to whatever power you want, I should say. All right? So it kind of depends on the type of calculator that you have, all right, how it does scientific notation. All right? So this one, let's see what we got here. I don't even know what this one does. I don't see it. Oh, there. This one's an EXP button. So let me try that out. So if we go 1.32 EXP 10. Okay. Ooh, that's definitely not what it is, unless I did something, push a button I didn't need.
What you accidentally did was 1.32 times 10 to the 23rd times. Wait, no, never mind.
There it goes. I just pushed an extra thing I didn't need there. All right. So this one has an EXP. Some of them are going to have an EE. I don't think you're going to see much different anything else. Some of you won't even have it if you don't use a scientific calculator. 4-function guy won't work. If we have one going the other way, like this, okay, so again, all right, we need to have one number to the left. So I count 1, 2, 3, 4, 5, 6. All right, so this would be times 10 to the 6th. But because we have a small number, that we started with a small number rather than a large number, then we're going to have a negative exponent. So it would be 4.63 times 10 to the negative 6th. Right? So if you have a small number, you're going to have a negative exponent. If you have a big number, you're going to have a positive exponent. Kind of makes sense. All right, exact kind of what how it works. You can actually do. There's some problems on this where you're going to add or multiply and divide. You can actually do that without even using a calculator. So, for example, they have a 4 times 10 to the 8th, and they put it in parentheses, and they go 5 times 10 to the 4th. You say, okay, well, how do we do that without a calculator? Well, really, you're just going to take these numbers here and here, and we're going to just go ahead and multiply those. So that's 20 times 10. And then if we multiply, what do we do with the exponents? Yeah, we just add them. So that's going to be 12. Okay, but notice that it's not in the right form, right? Because we need a decimal point to be here. So we have to move one more time. Okay? Well, that's not a big deal. I'll just add one more to the exponent. Okay? So you really don't even need to know a whole lot about scientific notation to do these problems. Okay? You surely can use your calculator, it's not a big deal. It's just you don't need to. Same thing with division. So if this is 15 times 10 to the 20th, and this is 5 times 10 to the 12th, okay, and we're dividing, well, we'll divide that. That's going to give us 3 times 10. And what do we do with the exponents in this case? Yeah, we're just going to subtract them. That gives me 8. I don't have to worry about moving anything around, so I just got a 3 there, so it's good to go. All right. So you can just use the properties of exponents here to do all these scientific notation things. It's not, you don't need a calculator. You can, but you don't need it. That's pretty much all there is to the scientific notation. Most of the stuff on here was with the negative exponents. I'll give you some of the negative exponent ones to practice on. Questions on any of those? Okay, so I'll give you some of these to practice on, and then please feel free to take a break if you need to. We'll go over them. I'm actually going to have to go over to whatever building that one is and run off your quiz because I had to make a couple last minute changes. So I'm going to do that, and then I'll come back and we can go over these, and then I'll give you more opportunities to ask me any questions that you would like on anything for your test. I guess we have to look at that supplement, which would probably take us about 2 minutes, if that, because it's really short. Not even sure why they have it in there, but we'll do that. So let me write down some problems that we're going to do. And some other people walked in too, so I'll give them their stuff. So supplement 5.2 says, let the functions f and g be defined by f of x equals x squared plus 1/3 x plus 4/5, and g of h it uses here, h minus 3/4 in parentheses times h plus 8. So A wants us to figure out what f of -3 is. So we're going to take that -3 because this is an f of x. I'm not exactly, I know you did some function stuff in 60. So this f of x here, f of -3, so that 3 is going to go wherever you see an x. Alright? So this would be equal to -3 squared plus 1/3 times -3 plus 4/5. So -3, that's 9. This is going to be -1. It's going to be 4/5. I would probably just use my calculator on this, clear all this junk out of here. 9 plus 1 negative plus 4/3. 9.3 repeating. Okay, that's that one. Alright, so you're just substituting out value in. Do the same thing with the other one. B, g of -5/4. So 5/4 negative minus 3/4 times -5/4 plus 8. Okay, so wherever I see a variable, I'm going to put that value in. Seriously, here, let's leave that alone. So this is going to be negative 2. Then I'm going to have a negative 5/4 plus 8 here. Okay, I guess I could actually figure out what negative 8 plus negative 5/4 is, but I could also distribute this 2 inside. So that gives me 10/4 plus a negative 16. That's going to reduce though. So I'm going to get, this is going to be 2.5 and a negative 16. So I'm going to get negative 13.5 there. That was the supplement. And again, I'm not exactly sure why they showed that to you. But there it is. Okay.